you have one overall step. Say, for example, the example that we gave you at the beginning when we started talking about the state function here, is that you have hydrogen gas, oxygen gas reacting with one another. Now, you end up, when you collect the product, hydrogen reacting with oxygen gas, and you end up with liquid water. That's the overall process. Okay. Now, the overall process can actually be separated into multiple steps. The first is that the gas state oxygen gas and the gas state hydrogen reacting with one another. Initially, you form a gas-phase water. Now, that gas-phase water, the formation of the gas-phase water is actually a chemical process. Two reactants react with one another, you end up with a product. The product is in a different physical state. Okay. Now, the gas water at room temperature will condense back into liquid water. So in this case, between the reactions, in this one-step reaction, hydrogen gas reacting with oxygen gas, giving you water there, we can actually separate it into two different steps. First is the formation of gas-phase water. And then the gas-phase water condensed back into liquid-phase water. So the Hess law says if a reaction is the sum of two or more reactions or two or more steps, then the change in enthalpy for the overall step equals to the sum of the enthalpy change for each of the steps. So going from gas, hydrogen gas, oxygen gas to gas water, there is a certain amount of energy released. Okay. The formation of the hydrogen-oxygen bond in water molecule releases energy. And that compared to the breaking bound between the hydrogen-hydrogen atom, oxygen-oxygen atom, and the amount of energy required to break the old bound is less than the amount of energy that is released when the new bound is formed. And then from gas water to liquid water, condensation, that's an exothermic process. Heat is again being released. So according to this particular statement of Hess law, that reaction, we can separate them into two different steps there. So the enthalpy change for the overall process equals to the enthalpy change for the first reaction, chemical reaction, plus the second process, the physical process, condensation. Okay, so that's what Hess law is all about. And here's an example in talking about that. So if you have hydrogen gas and oxygen gas, you will form water in the gas phase first, and then the gas will condense back into the liquid there. So this particular process, it's an exothermic process, release 44.0 kilojoules of energy. And this particular process, going from hydrogen gas to oxygen gas, releases 241.8 kilojoules of energy. Now, according to Hess law, these are the energy involved in each of the steps. The overall step, going from here to here, the overall step, the enthalpy change for the overall step equals to the sum of these two numbers here. Negative 241 plus negative 44, you give you negative 285.8 kilojoules. And another example would be reacting carbon with oxygen gas. Now, you can get carbon monoxide first, and once you get carbon monoxide, if you supply excess amount of oxygen, then carbon monoxide can be converted into carbon dioxide. So this is the overall process, going from carbon oxygen directly in one step to carbon dioxide. Now this process can be separated, at least in theory, into two steps there. Now we can measure the enthalpy change for each of the steps. Negative 110 going from carbon oxygen to carbon monoxide, and then carbon monoxide with another oxygen and carbon dioxide. So you add these two numbers together, the overall enthalpy equals to the sum of those two separate steps. Okay? So that's what Hess law is all about. And then when you are asked to do questions, to do calculations about the enthalpy change, you're just simply adding things together, figuring out how much energy is involved in each of the steps. And then if an overall step can be separated into multiple steps there, you simply add all the energy in each of the steps together. Now, when we say add, you have to pay attention to the sign here. If this is positive, this is negative, you're not really adding them together, you're taking the difference there. Because when you add a positive number to a negative number, you're taking the difference between the two. Now, when you have both negative numbers there and you're adding them together, giving you an even more negative number there. So the negative sign in this case try not to understand the negative sign in the pure mathematical sense. It's a negative number, it's less than zero. No, the negative sign indicates the direction of the energy flow, meaning the negative sign means the energy is being given out to the environment. Okay, so that's what's going on there. So here's an example. How do we determine the enthalpy change for an overall reaction for the synthesis of ammonia? You have 3 hydrogen gas, 3 moles of hydrogen gas reacting with 1 mole of nitrogen gas and giving you with 2 moles of ammonia. Given this information, this overall process can be separated into 2 steps. And we know the enthalpy change for each of the steps. Now, what you need to do here is that this particular step, hydrogen gas reacting with nitrogen gas, you end up with N2H4. N2H4 can further react with hydrogen gas and give you NH3. So when you look at this question, where do I stop? Well, remember Hess law. This is the overall process. And one thing that you will discover is that when you add equation 1 and equation 2 together, you end up with the overall process. So we have so this is what's given there. Okay, so that's the first equation. Okay, the second equation, based on the given information there, the second equation is that N2H4 plus more hydrogen giving you 2NH3. Each one is balanced. Okay, and in this case, the enthalpy change for this reaction, negative 187.6 kilojoule. Now, if you add, when we say add, if you add everything together, okay, adding the equations together, you put everything on the left side of the equation, on both equations, you put them still on the left side, okay? And if you have 2 same terms, you add the total numbers together, okay? And then everything on the right side of the equation, you put them together still on the right side. So when you do the addition, you get 2H2 plus N2 plus N2H4 plus H2. So that's everything on the left side of these 2 equations. Okay. And that gives you N2H4 plus 2NH3. Now, once you have everything added together, you have N2H4 on the left. You have N2H4 on the right. So they cancel out. Right? And then 2H2, 1H2, 3H2. The overall equation, 3H2 plus 1N2, give you 2NH3. So this is the overall equation. You're just adding 1 and 2 together. Okay? So you end up So if you add those 2